can see that sometimes it seems very difficult to solve it, but always try to look at the limits and the function. So here you can see limit is pi and 0, and we all know that sine never holds for pi or 0. Sine 0 is 0, also sine pi is 0. Here is a mistake, this is 1. Cos 0 is 1, not 0. Sine n pi is 0, sine 0 is 0. It means that you can simply take out sine terms from the whole equation, because the limits is between pi, 0 and minus pi, so they will not hold. However, you will be having values for cosine. So now coming to this equation, we don't have this. Sine is not in, sine is gone here. Now coming to next, you have cosine here and you have cosine here. We know that when we will be applying cosine of 0, it will become 1. However, for minus pi, it will be plus pi again, so it would be cos of n pi. Similar thing goes here, cos of n pi, and the other thing would be plus 1. So it means that if we write an equals to v by pi inside 1 by pi, and now for this cosine 0, if I take n square outside, cosine 0 minus cosine of n pi, and since I said that cosine e minus sine, so minus pi would become plus pi, and same goes for this portion, so it will become minus 1 by n square, and inside it would be cos of n pi, and the lower limit is minus cos of 0. So it means that you will be having 1 here and you will be having 1 here. And if I roughly solve them, so you know that 1 by pi n square can go outside as a common. However, what would remain? This would remain as 1, and this minus would become plus. So 1 plus 1, 2. And similarly, this is minus cos of n pi, and this would become minus cos of n pi. So overall, that's why we have 2 divided by n square pi square, and 2 common as 2v, and inside it would be 1 minus cos n pi. So you can see that we take this common, so it would become 2v divided by n square pi square. Inside this is 1. So you can see if I write it on the top, so it would be an equals to v divided by n square pi square, that is common. Inside it would be 1, which is coming from this cos, then minus cos of n pi, then this minus would go inside, it would be minus cos of n pi, and minus plus 1. So ultimately it would be v divided by n square pi square, and inside it would be 1 minus 2 cos of n pi. So it means that we come up with a final formula. So even in the exam, if you simply write it here as 0, but you know the logic, or if you can write sine like I have written here, sine n pi 0, so that's fine. So finally you have to put limit only in the cosines. Any question on this? Any confusion? Okay, good. So it means that we come up with a formula for n, which is n equals to 2v by n square pi square into 1 minus cos of n pi. Now again, as I said, that we always look for even and odd n. So if we look for even n, so for even n, what happens that we know cos of 2 pi, 4 pi, 6 pi, all of them equals to 1, whereas cos of pi, 3 pi, 5 pi, all of them are minus 1. So it means that when they would be even, so 1 minus 1 0. So it means that for even n your an would be 0. So that's why we have 0. For odd n, so 1 minus and then there would be minus 1. Minus minus would become plus 1 and it would become 2. So for an even 2v by n square pi square, inside it will be 1 minus 1 which is 0. So become 0. An for odd would become 2v by n square pi square, and inside it would be 1 minus 1. So it would be 4v divided by n square pi square. So it means that if we finally go to the Fourier series, we can simply say that bn is 0 because we already see that it's an even waveform. So bn was 0, and a naught we calculated as v by 2, whereas for an only holds value for odd n. For even n it's 0. So we can put, so finally you can see that this is your final equation. And now if I expand it, normally we expand it for few terms to see how it looks like. So you can put n equals to 1. So when I put n equals to 1, I get this term. N equals to 3 because for 2 it's 0, and n equals to 5, I get this term. So it means that now this is how a Fourier series looks like. And if, like I said, that you have to draw a line spectrum. So for line spectrum, now in line spectrum, what elements will I be having? So I know this is, so this is 0, 1, 2, 3, 4, 5. So will I be having any at 0, any line at 0? This is spectrum, right? How do we draw spectrum? We draw spectrum by taking the values of the constants. So I know I have value a naught. A naught is 0 value, DC value. So it means that we will be having a line at a0. Do we have a1? Do we have a1?
I think we go 1, right?
Yes, we have a1 because this equation holds for odd n. So you can see that this equation holds for odd n. So we have a1. Do we have b1? Do we have b1?
No.
There is no b at all. So b is 0, whatever is the case. However, a is,
Because it's even, right?
sorry? Yeah, because it's even, yes. So you will be having something here. I'm not sure how much. You will be having something here from b's, sorry, from a's. Because b, there is no b. Similarly, you will be having 0, nothing from 2. Again, you will be having something from 3, 5, and so on. And yes, so this is how you actually draw the spectrum based on looking what, for example, if I was having a and b both, so what I will do, I will draw 1, I will draw a, and beside this I will also draw b and will label it as b, so that someone know that this is a and b both. But since in this case we don't have b, so we will be drawing only a values, and a values only exist for some of these. And like I said, that when you're going to draw this, you can put v as some value. Like if there would be any example, for example, if you can take this as 10, so the very first value would be, how much would be first value if I take v equals to 10? So this first value would be 5, right? Because here is 10 by 2, so the first value would be 5. Then here 10 times 40 divided by pi square, this would be some value, and so on. So this is how you draw a line spectrum, okay? Right.
So you have to times 10 times 3.
Yeah, 10 times 4 divided by pi square, 6.28. So 40 divided by 6, 5. So close to 5 something, I guess.
Yeah, 4.05.
4.0 something. So this would be your 4.0 something, and so on. And if I use the same way I was doing previously, that I was taking the Fourier series and then I was using omega equals to 1 and v equals to 1 and was drawing this waveform. So you can see that this was a triangular waveform, right? So more or less this has a triangular shape, although we have these smooth portions. Why? If you keep on, we will see in the lab sometimes that if you keep on, because in the lab you can just copy paste it for so many times. So you could increase the number of terms and you will see that this shape will reach to a triangular waveform. Right. Now there are few tutorial questions that are already on the VLE. So they are already on the VLE. So this question is exactly same as we have solved example number 1. The only difference is that here it's 10 and minus 10 in the example that we have solved in the class is V. But I would encourage you to solve this because it will tell your hand to have some practice of solving such equations. So the series would remain the same. The only thing is here it was V by pi, V by or something times V. Then this was a square waveform. Then the triangular waveform which we have just solved. So again here you remember it was V plus pi by V by pi and V minus V by pi. So again the question is same, that it's just the difference is that you have some numbers. So this is a good practice. You can solve this by taking these numbers and you can relate it with your lecture notes. This is something different, which is triangular waveform. We have done one example in which the waveform was symmetric around y-axis. You remember there was a straight line down there, and then we found a single equation starting from minus pi to pi. But in this case, is it even or odd? This waveform, is it even or odd?
This one because it has a mirror, right? I think.
Number 5. What is even if it is mirroring around the x-axis? Is it even? No. Is it odd? No. This is not even, not odd. So very good. Okay. So start attempting this question. Here is the solution as well. And you have 10 minutes, then I will also solve it for you.
It's number for 3.
You will see in the solution there would be means integration by parts is done slightly differently, but if you do it in your way, you will get the same formula. So out of these 2 pages are for tutorial, the other 2 are for the next tutorial. So you can just keep it and we'll use it No. Tutorials are not recorded for your lab, for your logbook. Logbook is only experiment. So this is where you practice.
Basically, it's exponential, so you put complex stuff on it, and then J's, yeah. You look at the spectrum, and dots, and really Alex, have a look at the last page.
Yeah, I saw
Beautiful.
the last.
Mm-hmm.
Ah, it's the explanation. I don't mind. It's an E. It's the power, it's all right.
You might not have paid it, there's a, you
I think it's the last one.
no, you give them that. This one, I'll do that.
Or just the fine, so or is it 4?
find A naught in your own way using the equation, not through this formula which is area by 2 pi. You know how to calculate A naught, right? A naught equals to 1 by 2 pi, 0 to 2 pi f of t. Okay, so let's solve it here. So we know that we have this function as 5 by pi theta, and this function has value from 0 to pi. Why? If we have a look here, you can see that it only has value from 0 to pi, whereas in the other half it's 0. So it means that it is much easier now. If you want to find a naught, so a naught is 1 by 2 pi 0 to 2 pi f of theta d theta. It's 1 by 2 pi, inside it's 0 to pi 5 by pi theta d theta, whereas pi to 2 pi its value is 0, right? Hello.
How did they get 0?
Sorry?
How did it come to 0?
Is it from
Because from the waveform we know that we have to go from 0 to 2 pi.
Okay.
First half we have this figure,
Okay.
and we all know how to calculate this. Although it's given here, but even if it is not, then we need to take points and find this. We have done this in the class several times.
Oh
how to
yeah,
find
that's
points
fine.
for this.
I'm just thinking.
And then for the other half, which is pi to 2 pi, the value is 0, right? Because it is 0 because it was in the graph in a way. Okay. So it means that this part is 0. So we are left with 1 by 2 pi 0 to pi 5 by pi theta d theta. Finally, if we take 5 2 pi square, inside theta is theta square by 2 0 to pi. Inside if we keep pi square minus 0, so finally it will be 5 pi square divided by 2 pi square to 2. So finally 5 by 4. You understood this, right? We simply applied the limits, and here we taken 2 outside, and finally we get the value as 5 by 4, which was a naught. Now if we come to finding an, so it's 1 by pi 0 to 2 pi f of theta cosine of n theta d theta. So it's 1 by pi, the value only exists from 0 to pi, which is 5 by pi, which is 5 pi theta cosine of n theta d theta. For the other half it's 0 as we know. So it means that here we need to find this integral that you have done in the class, that it will be done by integration by parts. So n, it's 1 by pi 5 by pi square. I will take it outside, inside the integral 0 to pi theta cosine of n theta d theta. You know how to solve it. So it would be first into integral of second, integral of, what is the integral for cosine? Sine n theta
over n.
divided by n minus derivative of first, which is 1, and sine theta by n d theta. This integration, the same integral we have solved in the class, so that's why I'm doing a bit straight. So theta sine n theta by n minus 1 by n square, and this minus would become plus because for sine the integral is minus cosine. So it's minus cosine of n theta, and the limit is from 0 to pi, and this has been done by, this whole thing is integration by parts. Okay. Now finally we have to apply limits. But before applying limits, again we know that this is sine term and this is cosine term. We know that sine pi is 0, 0 is 0. So we don't need to apply limits on this. We already know. We already know that this will go 0, whereas for the other part it would be 5 divided by pi square, and n square also common. Inside the only thing left is cosine theta 0 to pi. And finally if we apply limit here, 5 divided by n square pi square cos of n pi minus cos of 0. So it would be 5 by n square pi square, inside is cos of n pi minus 1. So it means that we have n this, and now solving it for finding it for even and odd ends. So an and even mean 2, 4, 6 and odd. Who will tell me that what is value for even? What would be an for even? So 0, right? Because cos of 2 by 4 pi would be 1, 1 minus 1, 0. Which means that an is 0 for even. And what is value for odd?
1.
So overall, what is an for odd? So for odd, this would be minus 1. Cosine of pi is minus 1. Minus 1, minus 1, minus 2. So minus 10 divided by. So minus 10 divided by pi square n square. So this was an, and since as I said earlier that this function is not even, not odd, so it means that for this function we'll be having a naught, an, and bn all. Using the same method, we can find bn. What is formula for bn? 5 and 5 by pi theta sine of n theta d theta, and we can easily solve it. And I will just write the final value. It's minus 5 because it's same as we have done previously, cos of n pi. And in this case, you can see that for if there is odd value, then this term would become plus, and if there is even value, this would remain negative. So it means that an was only here for odd, but bn is for all the values. And so finally, I will bring it here. So finally, if we try to write it, you will see that there is a DC term which was 5 by 4. Then for a naught, you can see that there is 1 3, 5. A naught was existing, so the an was there for odd value of n, whereas bn was for even and odd. So you can see that 1, 2, 3, 4, and you can see that with an everything is cosine. With bn, you have seen that when there was odd, so it was plus 5 pi. So here it is, and when this is even, you have seen it's negative. And finally, if you want to draw the line spectrum, so you can see that the BC was 5 by 4, so you have 5 by 4. Then 8, 1, you have both. You have A and you have B. A is minus 10 pi by 2, so that's why you can see that you have drawn it on the negative axis, and this is on the positive. Similarly, for 2 is not present in A, 2 is only present in B, so that's why you can see that in B you only have this blue, which is for B, and so on. So this is how you actually start with solving an integral and then coming up with a line spectrum. But again, I would say that this needs a lot of practice. So do practice in your own time so that you're good at solving integrals. There is another tutorial which is same as this one, but it has falling slope. So you can solve this at home. You can see that this is another tutorial which is same as the previous one. The only thing is that it was rising in this, but it is falling. So finally you will get slightly different equation, but you can do it. Any question? Yes.
You know the phase test on week 8, is it based on these tutorials?
Yes, most probably it would be, yes.
Is it MCQ?
I'm not sure at the moment, but I will see. I mean, most probably there will be MCQs because MCQs are easy to check, easy to mark. So, but I will let you know.